Look at this isolated node. It represents a powerful AI model, capable of reasoning, but totally disconnected from your files, databases, and local systems. The Model Context Protocol, or MCP, solves this isolation. It acts as a universal communication bridge, allowing your AI to securely reach out and interact with local data and custom APIs. To build this bridge yourself, you will only need three things: an installation of Python 3, the Anthropic MCP Python package, and a basic understanding of JSON. By building an MCP-compliant server, you write the integration once. Instead of writing custom glue code for every new model that gets released, you create a single, reusable architecture. This diagram lays out our architecture. On the left is your host application, housing the AI, which communicates through the MCP client in the middle. Our job is to build the destination on the right, the MCP server. The connection starts when the client sends an initialize request across the bridge. Notice the payload. It includes a JSON RPC version and a specific ID, like ID1. When our server replies to declare its capabilities, that response ID must exactly match the request ID. If the client sends a 1, the server must return a 1, otherwise the connection fails. This strict matching rule does not apply to one-way messages, called notifications. When the client confirms the setup is complete, it sends an initialize notification without an ID attached. Let's translate that to code. Start your Python script by importing the server object from Anthropic's official SDK. Next, instantiate the server object and pass it a recognizable string identifier. This gives your server a specific name the client can log during debugging. With those few lines, you have established a secure JSON RPC communication pipeline. The AI and your server can successfully talk to each other, even though we haven't given the AI any specific abilities yet. To make the server useful, we start by defining a tool. A tool is an executable function that lets the AI take a specific action, like writing a file or querying a database. Your server must advertise tools using the @app.listtools decorator, so the AI knows they exist. The critical part of this code block is the input schema. This schema is where most initial builds fail. You have to strictly define your tool's input parameters using standard JSON schema rules, or the client will reject the execution. Once validated, the @app.callTool decorator takes over. It accepts the arguments chosen by the AI, runs your underlying Python logic, and returns the result as structured text. Sometimes the AI doesn't need to take an action, it just needs context. That brings us to resources. Resources are read-only data providers. If the AI needs to read a system configuration file or pull a live database record to formulate its answer, you expose that data as a resource. You configure resources by assigning them a specific URI, like a file.path, and a MIME type. This ensures the client knows exactly how to parse the incoming text or binary data. Tools perform actions, while resources provide information. By configuring both on your server, you upgrade the AI from a passive text generator into an active agent that can read its environment and make changes. Some tool actions, like deleting a directory or executing a financial transaction, are destructive. You do not want an AI running those completely on its own. A feature introduced in the 2025 MCP spec called elicitation gives you a way to pause the execution and ask a human for approval. In your tool logic, you can trigger and overlays a UI prompt, forcing the user to confirm the action. Once the user types their confirmation and hits approve, the client packages that human response and sends it back down to the server so the tool can resume its work. Elicitation provides a necessary safeguard. It allows you to build complex, autonomous workflows while maintaining strict, accountable human oversight over sensitive operations. Watch as these isolated nodes snap together. This represents what we've just built, a fully capable server, connected securely from the initial JSON RPC handshake all the way up to executable tools and human safeguards. If you check your terminal, you will see the server actively logging a successful connection with your host application. Because MCP is an open standard, this exact Python script works across platforms. You can plug it into any compliant MCP client without rewriting a single line of code. Now that the connection is stable, you can expand your server by writing custom prompts or packing the code into a Docker container. You have the structural foundation to build